How do we use calculus to find the maximum of a function? Well, let's actually think about what the maximum point is right here. It's right there. Well, what do we know about this point that's special? Well, we know that the slope of the tangent line, or the derivative, is 0 at the maximum. I'm going to say that again. The slope of the tangent line, or the derivative, at our maximum value is 0. So what we're going to do is we're going to call this function f of x, and all I have to do to find the maximum is take the derivative and then set it equal to 0. So this is going to be a minus 8x plus 8, and then I'm going to set that equal to 0. Subtract 8 from both sides. I get a negative 8x is equal to negative 8. Divide by negative 8, I get x equals 1. So that looks about right on my graph here. It's not clear because the axis isn't labeled. What we do next is we're going to take this x value of 1 and we're going to plug it into the original equation to get my y-coordinate. So that's going to be negative 4 times 1 squared plus 8 times 1 minus 2. And that gives me a value of 2. So our final coordinate is an x value of 1 and a y value of 2. Right there. So this is the coordinate 1, 2. The question is, can we do the same thing to find minimums? Well, let's see if it's true here. Here's my minimum. What's the slope of the tangent line here? Well, it's also 0. So yes, we can do the same exact procedure. We're going to take the derivative, which is going to be a 4x plus 8. And we're going to take the derivative and set it equal to 0, right? Because the slope of the tangent line is 0. Solve for x. And then once we have our x, we're going to plug that back in to our original f of x. Okay, and when I do that, I get a value of negative 12. So our coordinate is negative 2, negative 12. And that does make sense if you're looking at this graph right here. All right, now, there's also a topic called optimization, which is really about getting the ideal solution to either maximize or minimize something. So this problem says, suppose you have 40 feet of fence and you're trying to enclose a rectangular garden. What's the maximum area of your garden, right? Or what's the maximum area that you can enclose? Same thing. So I have this graph right here, okay, and I know that if I make this an x, I guess it's not a graph, it's just a rectangle, then I have to make this x, okay? Well then, I know that this side, since I only have 40 feet of fencing, is going to be 40 minus 2x, because this is an x and that's an x. But I'm going to have to split that between this side right here and this side right here. So I have to divide that by 2. I want to make sure you believe me on this. Let's let x equals 10. So then if x is equal to 10, let me go a different color here, then this would have to be 10 because it's a rectangle. And then think about it. How much do we have left? Well, we have 40 minus 2 times 10, 40 minus 20, okay, equals 20 feet of fencing, but then we have to split it between this side and this side right here. So you divide that by 2, and that would be 10 for each side as well. That's important to know because you're going to have to label this picture properly in order to get the right answer. Okay, what are we trying to maximize? We're trying to maximize the area. So what I'm going to do is I'm going to say that area is equal to base times height. Well, what's my base in this case? Well, it's this. And how can I reduce that? Well, that's going to be 40 divided by 2 is 20. Negative 2x divided by 2 is a negative x. So this is my base of my rectangle. So I'm going to have base 20 minus x times my height. This would be my height. So that's going to be times x. So now my area is going to be 20x minus x squared. Now, how do I maximize something? Well, I take the derivative and I set it equal to 0. So my a prime is going to be equal to 20 minus 2x. And now I'm going to set that equal to 0. Subtract 20 from both sides. That disappears. I get a negative 2x equals negative 20. Divide by negative 2. And I get x equals 10. So I'm not done yet. I've just found the length of x that would maximize the area. What I need to do is go back to this picture right here and actually find what my values are going to be. And we actually have already done this, right? My x values being 10. Okay, this would be 10, and then this would be 40 minus 20 divided by 2 is also a 10 and a 10. And that makes sense, right? I only have 40 feet of fencing, and I've literally just had 10 plus 10 plus 10 plus 10. That does give me 40 feet of fencing. So that is going to give me an area of 10 times 10, which is 100 feet squared, or squared feet. And if you're not sure how I got this number, you can just think about taking your x value of 10 and plugging it in right there. All right, and that's the answer. We're done with that one. Okay, let's try another one. You have 40 feet of fence to enclose a rectangular garden, but this time you're along the side of a barn with your rectangular garden. So what's the maximum area that you can enclose? So do you see here how now we only have 3 sides that we're dealing with? So if this is an x and this is an x, then this is going to be 40 minus 2x, because we still have 40 feet of fencing. We don't have to divide by 2 because this side of the garden is against the barn. So what's our area? Again, it's base. This is my base. This is my height. Okay, it's going to be area of my garden is base, 40 minus 2x, times my height, which is x. I'm going to go ahead and distribute that x through, and I get a 40x minus 2x squared. Again, I'm trying to maximize something, so I'm going to take the derivative. So I get a prime is equal to 40 minus 4x. I'm going to set that equal to 0. I'm going to subtract 40 from both sides. That gives me a negative 4x equals negative 40. Divide by negative 4. And again, I get x equal to 10. But we're not done. We have to figure out what the maximum area is. So let's go ahead and let's plug that in. So here I'm going to have 40 minus 2 times 10. And that's going to be 40 minus 20, which is 20. So I'm going to have 20 on this side, and then my x here is just x, or in other words, it's just 10. So my area is going to be equal to base times height, in this case 20 times 10, which is equal to 200 squared feet. And that's my answer. All right, there's going to be another video on optimization. It's an extremely important problem. I hope you can watch that as well. You will need it. Thank you.